There is a place 384,000 kilometers away from you. You can see it tonight. Just step outside, look up, and there it will be. Cold, round, silent, always the same, every night for as long as humanity can remember. But here's the strange thing. Throughout the entire history of humanity, across thousands of years of observation, across billions of nights when people gazed at the sky and invented gods, drew maps, and wove myths about tides and werewolves, no one, not a single person on Earth, has ever seen the other side of the moon. Never. Not in ancient Egypt, not in Mesopotamia, not in the Greek era, not in the Middle Ages, not with the naked eye, not through Galileo's telescope, not from the peaks of mountain observatories, not from the portholes of the first airplanes. One side is forever turned toward us, the other forever turned away from us, in darkness, in silence, in absolute seclusion for billions of years. And this isn't a poetic metaphor. It's a physical fact that has existed longer than life on Earth, longer than fish, dinosaurs, or mammals have existed, longer than anything we call history. What is there? Why is it like that? How is it different from the side we see every night? What happened when humans finally got there? First in photographs, then on probes, then with our own eyes. And what did the Artemis II crew see when they flew around the moon in April 2026 for the first time in half a century? Today, we're going to the far side of the moon. I'll tell you everything, from the physics that has kept it hidden from us for billions of years, to the actual images the crew just took from the Orion spacecraft's porthole. Images that humanity hasn't seen in 54 years. Images that have changed the way we view our closest cosmic neighbor. And before we begin, remember one number: 4.5 billion years. That is exactly how long the moon kept its secret. By comparison, the entire history of human civilization, from the first Sumerian cities to the present day, spans about 6,000 years. That is 750,000 times shorter than the period during which the far side of the moon remained invisible. You would have to line up 750,000 human civilizations to cover the total time that the moon hid its other half. Tidal locking: how physics stole half the moon. Let's start with the most important question. Why does the moon always show us the same face? This is no accident, no coincidence, no mystery. It is the result of a physical process that has been going on for billions of years and has a precise scientific name: tidal locking, or synchronous rotation. And once you understand how it works, it will seem both very simple and absolutely incredible. When the moon first formed, about 4.5 billion years ago, following a massive collision between Earth and the protoplanet Theia, it rotated on its axis much faster than it does now. A single full rotation took just a few hours. Imagine, back then, a lunar day was shorter than an Earth day is today. The moon was young, hot, and fast. But Earth's gravity is not uniform. It decreases with distance according to a precise mathematical law. The side of the moon that was closer to Earth was pulled slightly harder. The side that was farther away was pulled slightly weaker. This difference created a deformation within the moon's body, a gravitational tide in the solid rock, a slight stretching along the Earth-Moon axis. And this deformation could not keep up with the moon's rapid rotation. Constant friction arose, a constant braking torque. Imagine a hand that, for billions of years without stopping, holds the brake on a spinning wheel. Gently, almost imperceptibly, but always, without pause. Year after year, millennium after millennium, million year after million year. Gradually, at a rate of 1/1,000,000th of a second per year, the moon's rotation slowed down, and at some point, the speed of the moon's rotation around its axis exactly matched the speed of its orbit around the Earth. One rotation around its axis equals one orbit around the Earth. 27 and 3/10 days there, 27 and 3/10 days back. The two movements synchronized perfectly, and ever since, forever. One side always faces us. The other always turns away from us. How long did it take? According to current estimates, the process of tidal locking took anywhere from several 100 million to about 1 billion years. In other words, about 3.5 billion years ago, the moon was already in a locked phase, just as it is today. This means that the first single-celled organisms on Earth, the most primitive bacteria, which were just beginning to colonize our oceans, were already living in a world where the moon always showed the same face to Earth. Even back then. Always. This is called tidal locking, and it is the standard fate of most large moons in the solar system. Charon, a moon of Pluto, is also tidally locked to its planet, so completely, in fact, that Pluto itself has become tidally locked to Charon. They both always face each other with the same side. Mutual tidal locking is an extremely rare phenomenon that exists in only a few binary systems throughout the entire solar system. Most of the large moons of Jupiter and Saturn, Io, Europa, Ganymede, Callisto, are also locked. Physics works the same way everywhere. Physics always wins in the end. Always. An interesting detail: the moon isn't perfectly frozen in place. Due to the slight ellipticity of its orbit and the tilt of its axis, it wobbles slightly relative to Earth, a phenomenon known as libration. Thanks to this, we can observe just over 59% of the moon's surface at different times. But you can't see the far side through libration. We're only talking about the very edges, and even then in a highly distorted form. The true far side, the one that never, at any angle or position of the moon in its orbit, faces Earth, remained an absolute mystery until 1959. Billions of years of mystery. 4.5 billion years. 2 different worlds on one moon. And this is where things get really interesting. The two sides of the moon are completely different, not just slightly different, radically, fundamentally, and astonishingly different. So much so that when a Soviet probe photographed the far side for the first time in 1959, scientists were completely shocked. They expected to see roughly the same thing they see every clear night. What they saw was something completely different. So different, in fact, that it took several months to make sense of what they had seen. The visible side of the moon, the one you've known since childhood, is covered with vast dark plains. They are called seas, even though there has never been any water there. These are solidified flows of basaltic lava that filled enormous impact craters billions of years ago. They cover about a third of the visible surface and create the moon's most recognizable face, dark patches against a light background. For thousands of years, people have looked at them and seen different things. Some saw a hare, some a woman with a basket, some a wise face, and some an evil spirit. Every culture came up with its own image for the same pattern. The far side looks completely different. There are almost no dark seas there, just 2 or 3 small patches. The far side is a continuous expanse of mountains, craters upon craters, relief piled upon relief. An ancient, pockmarked surface, continuously bombarded for billions of years, and never having received a cosmetic repair in the form of lava flows. No smooth plains, no face, only chaos. Primal, untouched chaos, frozen for billions of years. Every crater is a witness to an impact that was never meant to be erased. Why? The main scientific theory is that the crust on the far side is significantly thicker than on the near side. On the near side, the crust is thin, averaging about 60 kilometers. On the far side, it reaches up to 80 kilometers or more in some places. A difference in crustal thickness of 20 to 30 kilometers is enormous. When large asteroids struck the thin near side, lava from the interior flowed out and filled the craters, creating those very dark, calm seas. On the far side, the crust is thicker. The lava simply couldn't break through this barrier, and all the craters remained unfilled, just as they were after the impacts billions of years ago. Why, then, is the crust thicker on the far side? Here is an elegant hypothesis. When the moon was just forming after its collision with Theia, the visible side facing the hot, young Earth cooled more slowly. The far side, the one facing the cold cosmos, cooled more quickly, and the crust there grew thicker and more uniform. The Earth literally heated one side of the moon more than the other during its formation. And we still see this echo of early heating today, in the terrain, in the thickness of the crust, in the absence of seas. 4.5 billion years ago, Earth warmed one side of its satellite just a little more, and today we see that difference in the form of a mountainous landscape. That is what the long memory of geology means. There is another important aspect of this asymmetry that is worth understanding. The total concentration of radioactive elements, uranium, thorium, and potassium, on the near side is significantly higher than on the far side. This phenomenon is known as creep terrain. Rocks that are abnormally rich in heat-generating elements are concentrated specifically on the near side. This is yet another factor that sustained mantle activity and lava flows specifically there. The far side, poor in heat-generating elements, cooled faster and deeper, and remained a conservative repository of the ancient landscape. The Aitken Basin, a scar the size of a continent. There is something else special on the far side, something that, by the standards of the solar system, can be described as monstrous. The South Pole Aitken Basin, one of the largest confirmed impact craters in the entire solar system. Diameter, 2,500 kilometers. Depth, over 8 kilometers. For comparison, that's roughly the distance from Moscow to Lisbon, across a single crater. It's larger than the entire area of Western Europe. It's a structure that can be seen from a satellite as a single object, but standing at its bottom, you don't realize you're inside a crater. It's so enormous that if you were standing at the bottom and looked toward the edge, you wouldn't be able to see it. The edges stretch beyond the horizon, beyond the curve of the moon. The crater is simply too big to take in with a single glance from the inside. It's like standing somewhere in the middle of Europe and trying to make out its borders. This gigantic crater was formed by an asteroid impact of such monstrous force that it nearly pierced the lunar crust right through and brought material from the depths of the lunar mantle straight to the surface. Right there, at the bottom of the crater, lie rocks that are supposed to be found hundreds of kilometers below the surface. Material that geologists extract with great difficulty, and that helps us understand the internal structure of planets. Here, it simply lies on the surface, waiting, for billions of years. It was there that the Chinese Chang'e 4 lander touched down in 2019. It was there, in the deepest part of this massive scar, that humans first touched the far side of the moon. First glimpse, 1959, and the Soviet breakthrough. The first glimpse of the far side occurred in October 1959. And it was a moment of such magnitude that it is difficult to overstate its significance. The Soviet probe Luna 3 flew past the moon and took 29 photographs from a great distance. By today's standards, the quality was terrible. The images were blurry, grainy, and poorly lit. In some, the outlines of mountains and craters were barely discernible. Many details were nearly impossible to identify. By today's standards, it would look like a photograph taken through fogged-up glass at night. But these were the first photographs of something no one had ever seen before. The first map of an unknown continent. A door that had been closed for billions of years had opened just a crack, albeit through a keyhole. And in a world where everyone had known since childhood what the visible side of the moon looked like, these blurry spots meant more than any perfectly sharp images. Soviet scientists named the new features themselves: the Sea of Moscow, the Sea of Dreams, the Tsiolkovsky Crater, in honor of the Russian founder of theoretical cosmonautics, the Joliot-Curie Crater, the Sea of Lomonosov. These names were officially assigned and still appear on all maps of the moon. Soviet scientists literally wrote the first atlas of another world and put their names on it. An interesting detail: during their initial analysis of the images, the researchers, overwhelmed with excitement, made several errors in interpretation. In some blurry spots, they saw structures that weren't actually there. The human brain, wired to look for patterns, saw what it wanted to see. Later, higher quality images set the record straight. But the very fact that the first people looked at these images for hours, trying to make out details amid the noise and grain, speaks to just how powerful this discovery was, just how great the desire to see was. Pioneers always see a little more than is actually there. Apollo 8, the first human eyes. In 1968, people finally saw the far side with their own eyes. Not in a photograph, not through a lens, with their own. The crew of Apollo 8, the first people to orbit the moon, flew over it several times. Commander Frank Borman later told reporters, "It is the most inhospitable place I have ever seen. Nothing but craters, no flat surfaces, no landmarks. Just an endless field of destruction as far as the eye can see." Not a mountainous landscape, not a desert, a field of destruction. But the Apollo astronauts described the far side differently, through what they heard, or more precisely, through what they didn't hear. When the spacecraft passed behind the moon, communication with Earth was cut off completely and instantly. Absolute silence in their headsets. Not a single signal, no voices, no telemetry data, not even the faintest hum of the carrier frequency. Nothing. They were completely alone in the universe, for a few minutes on each orbit. All Apollo astronauts, without exception, described this moment when communication was lost as one of the most psychologically intense moments of the entire mission. Complete isolation, the kind that never happens anywhere on Earth. No view of Earth, no communication, just you, two colleagues in a cramped capsule, and craters below, and silence, thick as matter. Michael Collins, the pilot of the Apollo 11 command module, who orbited the moon while Armstrong and Aldrin were landing, said it was the loneliest feeling he had ever experienced, and at the same time, the calmest, as if all the noise of the world had been turned off with a single switch. 3 billion people on Earth, and not a single one of them exists, only orbit. Think about that. Collins orbited the moon alone in complete silence, while his two colleagues did what everyone would remember half a century later. And that silence beyond the moon, which he experienced again and again on every orbit. It was, in his words, incomparable. Late Heavy Bombardment, a photograph of the solar system's youth. It's worth saying a few words about why the far side has retained so many large craters. This is an important story, a story about what the entire solar system has gone through. In the early history of the solar system, about 3.9 billion years ago, the inner solar system experienced an event that scientists call the Late Heavy Bombardment. This was a sharp surge in asteroid and comet impacts, far more intense than the background rate that exists today. Over a relatively short period, by geological standards, numerous large bodies crashed into the inner planets and their moons. Some researchers link this event to the migration of the gas giants. When Jupiter and Saturn shifted into new orbits, they gravitationally destabilized entire belts of small bodies and sent thousands of objects into the inner solar system. It was a kind of gravitational billiards on a planetary scale. It was then that most of the large impact structures on the Moon, Mars, and Mercury formed. And the far side of the Moon has preserved the evidence of this bombardment intact, because lava flows did not cover these ancient scars. The near side was bombarded just as intensely, but then lava flooded in and concealed the evidence of that primordial attack. On the far side, it's all recorded, like in a book. Every crater is a chapter. The other side is like a photograph of the solar system in its infancy, unretouched, honest, and terrifying in its antiquity. There is nothing new there. All you see there are the scars from events that occurred back when there wasn't a single bacterium on Earth, back when Earth was a fiery ball covered by an ocean of magma. Magnetic anomalies, mysteries that remain unsolved. There is another aspect that is rarely mentioned in popular articles, and which shows just how much the far side remains a place of unanswered questions. Localized areas with unexpectedly strong magnetic fields have been detected on the far side of the Moon. This is strange for several reasons. The Moon generally lacks a global magnetic field. Its core cooled long ago, convection within it has ceased, and there is no protective field similar to Earth's magnetosphere. But at specific points, particularly concentrated on the far side, instruments on orbiting spacecraft are detecting local magnetic anomalies with an intensity that simply shouldn't be there. Where do they come from? One hypothesis: they arose as a result of impacts by large asteroids, which created temporary plasma clouds and magnetized the rock at the moment of collision. A powerful impact, a plasma flash, instantly magnetizes the rock as it cools. A kind of snapshot of the catastrophe, imprinted in the crystalline structure of the minerals. Another theory involves what are known as antipodal points, locations directly opposite the large impact basins on the near side. When a massive asteroid strikes one side, the shock wave travels through the entire body of the Moon and focuses at a point directly on the far side. The energy concentrates, and this too could have created specific magnetic structures. None of these hypotheses has been definitively proven. There are still many mysteries there, and that, to be honest, is one of the best things about science. The more we look, the more questions we have. The far side is full of questions. Chang'e 4. China solves a problem that no one else could solve. Following the Apollo missions, a series of orbital spacecraft systematically mapped the far side. In the 2000s, Japan's Kaguya captured high-resolution images and recorded HD TV video, the first truly detailed video footage of the lunar surface. The American Lunar Reconnaissance Orbiter created a detailed topographic map with a resolution of several meters per pixel, a map more accurate than any other for any celestial body beyond Earth. Chinese spacecraft added gravitational and mineralogical data. We knew the terrain. We knew the surface composition from orbit. But no one had landed, because there was one fundamental problem that seemed impossible to solve: communication. If you land on the far side, you're on the far side of the Moon. Between you and Earth lie 3,474 kilometers of lunar rock. No radio signal can get through that, no matter how much amplification you use, no matter how focused the antenna beam is. You are completely cut off from everything. And that made any mission to the far side technically impossible for decades. The problem seemed insurmountable until China solved it, gracefully, elegantly, and effectively. On January 3, 2019, the Chinese Chang'e 4 lander made the first ever soft landing on the far side of the Moon. It touched down in the Von Karman crater within the South Pole Aitken Basin, in a place where no man-made object had ever set foot before. For the first time, humanity touched something that had been inaccessible since the Earth's formation. How did China solve the communication problem? Several months before the landing, they launched the Kuekiao relay satellite, which means Magpie Bridge, and positioned it at the Lagrange point L2 behind the Moon. This point is located approximately 65,000 kilometers behind the Moon, and from it, both the far side of the Moon and Earth are visible at the same time. The relay satellite receives the signal from the lander and transmits it to Earth. A bridge between two worlds, an elegant technical solution that opened up access to the unreachable. A problem that seemed insurmountable was solved by adding a single satellite. Jade Rabbit and discoveries from the depths of the mantle. Chang'e 4 brought the Yutu-2 rover, Jade Rabbit No. 2. A small six-wheeled rover weighing about 140 kilograms. It began its work on a surface that no one had ever seen up close before. And this small rover made a discovery that overturned some geological models of the Moon. Yutu-2 analyzed the soil in the von Karman crater using an infrared spectrometer and detected materials that, according to standard calculations, should not have been present on the surface. Pyroxene, olivine, and other minerals indicating an origin in the Moon's lower mantle, brought to the surface by that monstrous impact that created the Aitken Basin billions of years ago. Pieces of what lies at immense depths are lying right on the surface. It's as if an asteroid had pierced the Earth's crust and ejected rocks from the boundary between the mantle and the core onto the surface. And now you can just walk up and take a sample. No need to drill a hole hundreds of kilometers deep. Just walk up and take it. In 2024, Chang'e 6 went even further. It became the first spacecraft in history to collect soil samples from the far side of the Moon and return them to Earth. Scientists obtained material that no human had ever held before. 1.9 kilograms of lunar soil from the far side, more than expected. Research on these samples continues and is already yielding new data about the early solar system, about how the first planets formed, and what the solar system looked like during its first few 100 million years. Every gram of this soil is an archive of an era when Earth was just becoming Earth. Artemis II, Return of the Living Eyes. And this is where the part of the story begins that took place very recently, just now, in the grand scheme of history. On April 1st, 2026, the Space Launch System, the most powerful rocket ever to fly into space, lifted off from Launch Pad 39B at the Kennedy Space Center in Florida, the very same launch pad from which the Apollos took off. That very concrete pad that remembers the Saturn V. On board the Orion spacecraft are 4 astronauts. Commander Reed Wiseman is an ISS veteran and one of NASA's top test pilots. Pilot Victor Glover is the first African American on a lunar mission, a man who will go down in history simply for being on board. Specialist Christina Koch is the first woman on a lunar mission and holds the record for the longest continuous stay by a woman on the ISS. And Canadian astronaut Jeremy Hansen is the first Canadian on a lunar mission, representing a country that is participating in the Artemis program through its navigation technologies. 4 people, 4 life stories, each of which has already become history. And each of them knew from the moment they were selected for this mission, that they were about to see something no living person had seen in the past half-century. The Artemis II mission. The first crewed flight to the Moon in 54 years. The first time since 1972, when Apollo 17 returned home. 54 years. In that time, entire generations of people were born and raised who have never lived in a world where humans fly to the Moon. For most of us, lunar flights are a story from a textbook, not a living reality. Artemis II changed that. On April 6th, the spacecraft flew past the Moon. Orion circled around it, including the far side, and the crew saw something no living person had seen since 1972. The far side with their own eyes. From the porthole, in real time. Without a television intermediary, without a photograph, without a screen, with their own eyes. Wiseman later recounted that the portholes had become smudged because the crew kept pressing their faces against the glass and couldn't tear themselves away. 4 adult, experienced, trained astronauts, and they were glued to the window like children. People who had undergone years of training, who had seen Earth from orbit, who were accustomed to weightlessness and G-forces, they were glued to the glass like children at the zoo. Christina Koch communicated with Earth and said, "Nothing prepares you for the moment when you see the entire planet through a single porthole, knowing that you'll see the same thing from the moon. It makes the wait unbearable. Photos that will make it into textbooks." Real photos. They exist. NASA published them for public access on nasa.gov immediately after receiving them. Everything is free, and everything is available to everyone. April 2nd, the first image of Earth taken from the porthole. It shows 2 auroras, one above and one below the planet, and zodiacal light, the faint glow of interplanetary dust along the plane of the solar system. This image, taken from a distance that allows the entire planet to be seen, is historic in and of itself. Then, Earth as a thin crescent from a vast distance, small, vulnerable, infinitely beautiful. Then the astronauts at the windows. Koch reads a tablet. Hansen looks out, his eyes fixed on what lies beyond. And most importantly, a photograph that will go down in history. The Oriental Basin, a massive multi-ringed impact crater on the western edge of the moon's far side. Its diameter is nearly 1,000 kilometers. It is about 3.8 billion years old. This is one of the best preserved multi-ringed basins in the solar system, a kind of textbook example of what the result of a truly powerful impact looks like. It is impossible to see the entire Oriental Basin from Earth due to the viewing angle. Orbital probes have photographed it from above, and those images existed, but the human eye never until now. The Artemis II crew became the first people in half a century to see this basin in real time, in all its scale, not on a screen, not through a telescope, with their own eyes from the ship's porthole. Think about it, 54 years. An entire generation has passed between these two views. The people who looked at the far side in 1972 have grown old. Some are no longer with us. And now, once again, the human eye is gazing at the side of the moon that Earth never sees. New generation technologies. What has changed in 54 years? It's important to understand, this mission isn't just about pretty pictures for social media, nor is it merely a symbolic gesture. Artemis II is the first step toward restoring humanity's ability to operate in lunar space after a 50-year hiatus. 50 years is a period during which a generation of engineers, doctors, radiation specialists, and spaceflight psychologists has come and gone. Technology has changed dramatically during this time. Digital cameras instead of film cameras. Onboard computers instead of analog computers. Modern spacesuits with built-in sensors. Radiation is measured in real time. Every physiological parameter of every astronaut is continuously monitored and transmitted to mission control. Navigation systems that the Apollo program could only dream of. GPS-like algorithms based on orbital data and constant communication. The images captured by the Artemis II crew represent a fundamentally different level of data quality. Resolution, metadata, geodetic reference to coordinates, spectral analysis. Scientists will study them for years, for decades. During one of her communication sessions with Earth, Christina Koch said something very poignant. Knowing that you're seeing something few people have seen before you is a unique feeling. It's not pride, not superiority. It's more like a sense of responsibility. You're seeing this on behalf of everyone who couldn't. For all the scientists who spent their lives studying lunar images but never flew there. for all the engineers who built this spacecraft, for all the children looking at the moon tonight, unaware of what lies on the other side. Radio silence, an unparalleled experience. There is something else worth mentioning separately: the moment of radio silence that astronauts experience behind the moon. This isn't just a technical detail in the mission protocol. It's an experience unlike any other in human history. Nowhere, never, on Earth, even in the most remote places on the planet, on Antarctic expeditions, on the peaks of the Himalayas, in the depths of the Pacific Ocean, aboard a submarine submerged to its maximum depth, in caves several kilometers deep, in the heart of the greatest deserts. You always have at least some connection to the rest of humanity. A satellite phone, an emergency beacon, a radio station, an emergency frequency. Someone knows where you are. Someone can respond. Someone is monitoring your signal. You are never truly alone. Beyond the moon, you are completely alone. Between you and the rest of humanity lies a 3,000-kilometer wall of rock. No technology exists that can penetrate it. No signal can pass through the moon. For several minutes during each orbit, you and your crewmates are completely cut off from everything you knew. From your family, from the voice of the flight controller, from mission control, which, under normal circumstances, knows more about you than you do yourself. From all of civilization. This is a different kind of isolation than anything on Earth. Because on Earth, isolation is always theoretically surmountable. You just have to walk, swim, or call out. Behind the moon, there's no way. Absolutely none. This isn't a test of endurance. It's another dimension of existence. NASA psychologists have studied this phenomenon in detail and discovered something interesting. When asked about those moments after their return, most Apollo astronauts described them as one of the most vivid experiences of the entire mission. Not the spacewalk, not the rocket launch, not the moon landing, but specifically those few minutes of silence behind the moon. Something happens there with the perception of time and space, something that cannot be replicated in training simulators. The Apollo astronauts experienced this in different ways. Some spoke of calm, others of anxiety, and still others of a strange feeling that they existed apart from history in their own little bubble of space. Michael Collins said it was the loneliest feeling he had ever experienced, and at the same time, the most peaceful. Two opposing feelings at once. The Artemis II crew experienced the same thing in April 2026. A few minutes of absolute silence. Technology has changed over the past 50 years, but physics hasn't. The moon still shields everything, and this silence has now been documented once again as a reminder of just how small we remain in the face of the scale of space, even when we reach the moon. Why do we need the moon? Resources, science, strategy. Why all this anyway? Why go back to the moon? Why build such huge rockets, spend so much money, and put people at risk? Because the far side of the moon is potentially the most valuable place in near-Earth space. There are several reasons for this, and each one is significant in its own right. First, water ice. At the moon's south pole, there are craters that have never been touched by sunlight, not since they formed billions of years ago. Eternal shadow, geometrically enclosed regions where not a single photon has ever penetrated. The temperature there is minus 240 degrees Celsius, colder than the surface of Pluto, and there is water there, frozen, but it's there. This has been confirmed by several orbital and impact missions, including LCROSS in 2009, which deliberately crashed into the lunar surface and detected water in the ejected material. Water on the moon isn't just drinking water, it's hydrogen and oxygen, the components of rocket fuel. The moon, as a space refueling station, has the potential to drastically reduce the cost of long-distance interplanetary missions. Instead of hauling all the fuel from Earth against its powerful gravity, spacecraft can refuel on the moon, where gravity is 6 times weaker. This transforms the entire economics and logistics of exploring the solar system. Second, helium-3, an isotope that exists in virtually no significant quantities on Earth, but which the solar wind has been driving into the lunar soil for billions of years. On Earth, helium-3 is produced in negligible quantities as a byproduct of tritium decay in nuclear warheads. On the moon, there are tons of it in the soil. Helium-3 is a potential fuel for the fusion reactors of the future, reactors that produce energy without long-lived radioactive waste. According to some estimates, the moon's helium-3 reserves are sufficient to power the entire Earth for many thousands of years to come. Just a few tons of this substance would be enough to provide a country the size of Germany with electricity for a year. An important caveat: fusion using helium-3 has not yet been practically realized, but technological trends indicate that this is a matter of decades, not centuries, and the moon is already preparing for its role as a supplier. Third, and perhaps the most intellectually fascinating, is radio silence. The far side of the moon is the quietest place in the radio spectrum anywhere near our planet. The moon completely shields all radio noise from Earth's civilization, from billions of phones, TV towers, radars, Wi-Fi routers, satellites, and radio stations. For a radio astronomer, it's like having a perfect anechoic chamber, only the size of a celestial body. A radio telescope on the far side could listen to the universe at frequencies inaccessible to any ground-based observatory. The low frequency range below 30 megahertz, where Earth is literally screaming with its radio stations and where the ionosphere blocks signals from space, would be accessible in complete silence from the far side of the moon. These are the frequencies at which we can detect signals from the first stars that ignited after the Big Bang. To study the dark ages of the universe, the period before the first galaxies, about which we know almost nothing, and theoretically, frequencies on which signals from other civilizations might be present, if they exist somewhere in the universe. The new space race. The stakes have risen. This is where the new space race is in full swing. It's not like the one in the 1960s, when it was all about symbolic supremacy and propaganda. It's different. China is moving toward a permanent base on the moon by 2035, an officially declared national goal backed by specific missions and funding. Chang'e 4, Chang'e 5, and Chang'e 6 are not isolated experiments. It is a sequential program, with each step leading to the next. Through the Artemis program, NASA is moving toward Artemis II, the first human landing on the lunar surface since Apollo 17 in 1972. The first woman on the moon, the first person at the South Pole, the first person to set foot on those very craters that are perpetually in shadow, where ice may lie. For the first time in history, two great technological powers are moving simultaneously and in parallel toward a single goal. And this isn't cooperation, it's competition. And the stakes are no longer about planting a flag and taking a nice photo. The stakes are in resources, in presence, in long-term strategic advantage. Whoever establishes a long-term presence at the South Pole first will gain access to the ice reserves and set the terms for their development. Whoever deploys infrastructure first will set the rules and standards for all subsequent players. This isn't the Cold War of the 1960s, when it was all about symbolic supremacy. This is a struggle for real resources in a real place. The moon is no longer just a symbol. It is becoming the next territory for humanity's real exploration. Conclusion. We are just beginning to read this book. For billions of years, the moon kept its secret. One side faces us, the other turns away. In 1959, we photographed it for the first time. Blurry, grainy images that we stared at for hours. In 1968, we saw it with our own eyes and called it an endless field of destruction. In 2019, we landed there for the first time and found traces of how planets were born right on the surface. In 2024, we collected soil samples from the far side and brought them back to Earth, 1.9 kilograms of untouched history. In 2026, Artemis II flew around it and brought back new images. The first human views of the far side in half a century. Every step is a page, and we're just beginning to read this book. The most important pages lie ahead. Artemis III, permanent bases, radio telescopes in craters, listening to the first stars, extracting ice from the perpetual shadow, and one day, people living on the side of the moon that is never visible from Earth, gazing at a sky where there is no Earth, only stars and absolute silence. The far side of the moon is no longer a complete mystery. We know its topography, we know its composition, we have landed on it, collected samples, and flown around it with our own eyes once again. But every new step raises new questions. Why exactly is there such asymmetry between the two hemispheres? What exactly happened to the Aitken Basin deep underground? How far did that impact penetrate? What does the ice look like from the inside in the permanently shadowed craters? Is it a monolithic mass or a loose mixture with regolith? What will a radio telescope hear in the absolute radio silence of the far side, if one is ever built? What other minerals lie there, untouched, lifted by impacts billions of years ago, waiting for their jade rabbit? These questions are waiting to be answered, and the people who will find those answers may already be here. Perhaps one of them is watching this video right now. The moon is not a spare planet or a tourist attraction. It is a scientific laboratory 4.5 billion years old. It is a refueling station for future interplanetary spacecraft. It is a radio observatory with zero background noise. It is a geological archive recorded before the emergence of life. And the far side? That's its best, most honest face. Links to all the real NASA images from the Artemis II mission are in the description of this video. Everything is free and openly available on nasa.gov. Download, watch, and check it out for yourself. These aren't renders or illustrations. These are real photos taken by people who are alive today, who pressed their faces against the portholes and couldn't look away. I hope you enjoyed the video. If you did, please give it a thumbs up. It helps the channel grow and create more content like this. Subscribe if you haven't already. Artemis III is just around the corner, and there will be a separate, in-depth video about that.